So here we are with a problem I always like a lot. This is an evil genius problem. Those are the most fun. Okay, this evil genius problem has to do with the sun and the earth. I mean, if you're going to be an evil genius, might as well be a big one. So the sun and the earth, it says, are pretty far away. Of course, we knew that. Here's the sun. And I'm going to have trouble drawing this to scale, so I'll do the best I can. Here's the earth, much smaller, very far away. So then the distance is 1.5 times 10 to the 11 meters. And so, sun to earth. And the evil genius has this idea. Evil genius says, if I could charge the earth and charge the sun, then I could exert an electrical force of repulsion between them that would equal the gravitational attraction, and therefore there would be no net force on the earth, and the earth could happily go its way without being tied to the sun. Right. So, of course, what we're saying here is that normally the earth has a gravitational force which is attracting it to the sun, which is what keeps us in our orbit, and evil genius wants to make an electric force which is equal but opposite, so it's therefore repulsive. Okay, sounds like a tough job even for an evil genius. So how can we do that? Well, the forces have to be equated. So that says that the gravitational force must be the same as the electric force. Okay, we know what the gravitational force is. It's actually given in the problem. And so what we're going to do then is set that equal to the electric force, and that's where the physics principle comes in, of course, because charges are ones which attract each other or repel each other. If they're like charges, they repel. So therefore, we need to have like charges on the sun and the earth that would cause a repulsive force between them, and that would be given by K Q1 Q2 divided by R squared. So then, to make life easy, let's say that Q1 and Q2 are equal. There's the same number of charges on both, and so then this becomes KQ squared over R squared. So that's F gravitational and F electric because they're equal. Great. So what are we trying to find? We're trying to find Q. How much charge does the evil genius need in order to make this work? So now, here's algebra. We now have to say R squared FG, or FE, doesn't make a difference. R squared times that divided by K. Take the square root of that, and you wind up with Q. Okay. So Q then, put in all the numbers. It says that Q is this 1.5 times 10 to the 11th meters, quantity squared, times the gravitational force, which is given as 3.55 times 10 to the 22 newtons. And this has to be then divided by K, which is a constant, 9 times 10 to the 9th, Newton meter squared per Coulomb squared. Great. The meters squared, because that was squared, and the newtons all go. Coulomb squared in the denominator comes up on top, take the square root, get coulombs. So we're going to wind up with a charge, and the charge is 2.98 times 10 to the 17 coulombs. Now, we love to apply the test of reasonability to things. Does that seem like a reasonable answer? What the devil is 10 to the 17 coulombs like? Phew, not much experience with that one. Suppose that we have, let's see how many electrons it is. Each electron carries a charge, then E charge is 1.6 times 10 to the minus 19 coulombs. So how many electrons then would it take to carry that number? Of course, the answer to that turns out to be, oh boy, 1.86 times 10 to the 36 electrons. Wow, it's a lot of electrons. Are there even 10 to the 36 electrons around? Yeah, it turns out there are, actually. an Avogadro number, if you remember your chemistry, is 10 to the 23rd. 6.023 times 10 to the 23rd, right? That's an Avogadro number. And that's, so really there are a lot of electrons. It turns out that, here's what would happen. There are about 10 to the 28 electrons in each person. So if we got 10 to the 8th people to give all their electrons, then we'd have this number of electrons available. So let's see, 100 million people. Can we get 100 million people to give up all their electrons to the evil genius? I'm sure the evil genius would probably have some sort of an appeal on the internet that would say, free the earth. Donate your electrons by sending them to, where would you send electrons? Oh, I know. Have to have a website. Turns out I checked this, and evilgenius.com isn't available. There's nothing on that site now, but it may show up sometime. But Super Evil Genius is available. So if you'd like to start this ball rolling, of course, what will happen if this does occur? Never mind all the complications of having not only the Earth charged, but also the Sun charged with the same number of electrons. I guess they have to run a similar campaign on the Sun. And what would you do with all the positive charges? Well, never mind all that, but even if you could do a lot, what would happen? Well, the Earth normally orbits around the Sun in this fairly circular fashion. And of course, if you turned off the force, it would just keep going straight. Bye-bye, Sun. Off we would go into the wild yonder. Not very blue, I don't think, out there. So I'm not sure you want to do this. This campaign may be doomed. You may not be able to work it out. But that's how many coulombs of charge will be needed to make it go. All right.